Hi, this is Team Pluto is a Planet. My name is Jared Riley, along with Corey Reyna, Shannon Williams, and Dr. Colleen Bailey, who is our faculty advisor. We are at the University of North Texas in Denton, Texas. Our project is over machine learning, and machine learning requires three things. It requires a good data set, a good learning algorithm, and a really good GPU. Luckily, NASA provided a small stipend so that we would be able to get the resources that we needed for any project that we chose. And so in our case, we ended up grabbing a 3080 Ti, which was extremely helpful in a project such as machine learning and doing classification. More specifically, we said machine learning, but our project is over dust storms. Dust storms can start and be in a small area. It can also encompass the entirety of the planet itself. And that can be a huge issue to the success of the mission, but also the safety. The safety of a crew going off to a planet like this, far away from home. And so when we heard about NASA Minds first back in November of 21, we thought, okay, we want to come up with a really good project, but we also want to do something that's meaningful. We thought, okay, well, maybe we can do geographical mapping, and we found that 90% of the surface had been logged, and we moved to instead dust storms. We had seen the movie The Martian. It portrayed a doomsday scenario, and we thought if it's anything close to that, we want to tackle that problem. Safety is also one of NASA's 5 main points that it focuses on. And thankfully, NASA takes a lot of time to ensure the safety of a team, and those dust storms are not as portrayed on The Martian, but they are still a concern. Wind speeds can average anywhere between 10 to 20 miles per hour. The Viking lander actually clocked wind speeds up to 70 miles per hour. And it can cause problems within machinery and also cover solar panels, which do charge batteries. And we're talking about the safety of people and a crew. And so we want to be certain that all our bases are covered. Amongst the chip shortage, we were still really lucky to get our hands on a GPU like this. We had proposed a TX2, and that was just a small model, maybe to put on a ship or on a satellite. But for the moment, we're having to withhold until the second semester of our senior design year. The data set that we created, we had two things. We had Mars equator photos, and we also had locations of those dust storms. And so if you can imagine, we had a blank image, and then we had another document that gave us locations. And so we had to do some math and really understand how to take a round object and map it to a square image, and then get the computer to understand exactly where that dust storm was. And so amongst the 3 months that we were provided, I'd say anywhere between 90 to 95% of it was spent on creating that data set and making sure it is as good as possible. Again, a strong data set is what makes the machine learning model. After that, we were able to use that vision transformer like I talked about. We're extremely proud of the results that we got and extremely excited. We found that our data set reached 100% accuracy with only 170 epochs, which is how many cycles it goes through within the model itself. And we're extremely stoked for the future. Looking forward to, again, either increasing the number of parameters that we can see within just a picture itself, not just a dust storm, but also the temperature based off of the location of Mars in relation to the sun, or also the wind speed if we move into that move in that direction. Ultimately, we're extremely grateful just for this opportunity, and thankful to NASA for providing it. And thank you to everyone watching this video and supporting us along the way.